and today I will be present the operation process of Moldflow software. First, we need to import the CAD model. And the model I choose is mouse. The mesh tab I'm using is your domain. And next is to generate the mesh. And using the software Moldflow. After that is we move on the core field pack and work analysis. And what we need to select in the setting is exactly the core field pack web sequences. And we need to click the select a specific material within the polyfilm RIPP 3625 series. And the manufacturer I select is a Schulman GmbH. And the specific trade name is polyfilm RIPP 3625 CS1. And in the material details and description, the family name is polypropylenes aggravated SPP. A specific trade name is polyfilm RIPP 3625 CS1, and the manufacturer is a Schulman GmbH. The recommended mold surface temperature is 60 degrees Celsius, and the mill temperature is 200 degrees Celsius. And the recommended mold temperature range goes from the median of 40 degrees to a maximum of 80 degrees. For the mill temperature range, the recommended median is 180 degrees, and the maximum is 220 degrees, with an absolute maximum melt temperature of 230 degrees. Lastly, the injection temperature is set at 110 degrees, and the maximum shear stress limit is 0.25 MPa. And the maximum shear rate limit is 100,000 reciprocal seconds. And for the rheological properties of select material, the default viscosity model is the coarse WLF model. The default viscosity model is and the transition temperature is 122 degrees. Within the thermal properties, it can be seen from the chart at the highest specific heat occurs at 118 degrees. Additionally, from the thermal conductivity data, we can find that the highest thermal conductivity occurs at 60 degrees. Within the PVT properties, the melt density is 1.2309 grams per cubic centimeter, and the solid density is 1.3717 grams per cubic centimeter. And here I have set one injection location. For the cooling circuit dimensions, the x-axis is 76.79 millimeters. The y-axis is 106.77 millimeters, and the z-axis is 28.94 millimeters. And the channel diameter is 10 millimeters, and the circuit is established at a distance of 25 millimeters. And I choose to align the cooling circuit along the y-axis with the part. The number of channels is 2. The distance between the channel center is 30 millimeters. And the distance extending beyond the part is 50 millimeters. And then click Finish. And for the process setting, the melt temperature is 200 degrees. The mold open time is 5 seconds. And the injection, packing, and cooling time is 30 seconds. Then click Finish. Next, we can analyze the simulation results. For the fill time, the total fill time is 0.4219 seconds. For the pressure at VP switchover, the maximum pressure inside the mold reached 27.74 MPa. And for the flow from temperature, we can see a drop in temperature in the middle section to about 196.6 degrees. It's because this specific location is where the weld line is formed. And the bulk temperature is 33.29 degrees. And this is the XY plot of pressure at injection location. The horizontal axis represents time, and the vertical axis represents pressure. After filling at 0.43 seconds, the pressure remains stable at 46 MPa for about 5 seconds. Next is time to reach injection temperature. And next is the frozen layer fraction. And next is for voice centered. It is indicated by a purple cross in this, and the result shows excellent left-right symmetry. And this is frozen layer fraction at the end of fill. Moldflow. This is core orientation. And this is skin orientation. For the pressure, the maximum injection pressure reached 46.15 MPa. For the shear rate, the maximum volume reached 29231.7. For the volumetric stringage, most area of the methane body remain within a uniform blue stringage band between 1.459% and 3.319. For the wheel lights, the seal lubrication resource shows a melting angle of 135 degrees. And next is wear patch. And for the total displacement, most of the surface on the mouse body remains in a blue-green safe zone below 0.0488. And confirming excellent dimensional accuracy after molding. And for all effects X component, the flow rate is precisely stabilized at 4.234 liters per minute. For all effects Y component, the maximum deflection displacement range between 0.1825 mm and minus 0.1067 mm. Confirming uniform shrinkage control, and for all effects, Z component, the volumes range between 0.0941 mm and minus 0.0192 mm. Confirming that the product has extremely high and stable precision in a high direction. For all effects, normal component, the maximum normal deflection perpendicular to the product surface reaches only between 0.1671 mm and minus 0.1726 mm, confirming very minor waviness on the cosmetic surface after injection. And that concludes presentation. Thank you.
谢谢。